Okay, so let's take a look at your oxidation number homework questions. So in the first question it says, determine the oxidation number of, and for A is S and SO2. Okay, so we're looking for the S. We know the O2. It's oxygen, and we know oxygen is normally -2. So there's 2 times -2, and if you call S X, X plus 2 times -2, and that has to equal 0. So 4 minus, X minus 4, so X should equal 4. Okay, that's for the first one. The next one is Cl in HClO4. So we know H is +1, Cl is X, and we know oxygen, there's 4 of them, is -2, and that should equal 0. So 1 plus X minus 8, or X minus 7, equals 0. So X should equal 7. Okay, so it's just as straightforward as that. The third one is S in SO4. Okay, so again, we don't know the S, it's X, and there's 4 oxygen, and they're -2, and the SO4 has a charge of -2, so that has to be equal to -2, because this is a polyatomic ion, right, that has a charge of -2. So X minus 8 equals -2, take the -8 over, X equals 6. The next one is Cr in Cr2O7, and it has a charge as well of -2. So we don't know what the Cr is, so it's X, but there's 2 of them. And there's 7 oxygen, so plus 7 times oxygen's oxidation number is -2 equals the overall charge, which is -2. So 2x minus 14 equals -2. Take the minus 14 over, it becomes positive. So x equals 12. 2x, equals 12. So x should equal 6. And the last one in number 1 is MgI2. And it wants to know what's the I. Okay, so this is the X. So find Mg on the periodic table, and when you do, it's in that second column, so it's going to be +2. +2 plus 2 times X has to equal 0. Take the +2 over, 2x equals -2, x equals -1. Easy enough? Okay, so that's question number 1. Oh, actually, it's question number 39. It's close to 1. The next question, number 40, says, determine the oxidation numbers of the nitrogen in each of the following. So in the first one, it's N2O. Okay? So we're looking for a nitrogen, and there's 2 of them, so 2x, and oxygen is -2, has to equal 0. Take the -2 over, divide, x should be equal to 1. In B, it's just NO. So x plus a -2 equals 0, x should be equal to 2. In the next one, NO2. So x plus 2 times -2 equals 0, x should equal +4. Next one, NH. I do have my glasses on, but the light isn't good where I am, which happens to be sitting in front of the fireplace, in case you were wondering. H3, so x plus 3 times -1 equals 0. Okay? Ooh, is it -1? Hang on a sec. Yeah, I think it's -1. And so I take this over, and I end up getting x equals 3. I don't think that's right. positive 1 because it's not negative 1. Who said negative 1? That's crazy. X equals 3 equals negative 3 when I take it over. I was just doing the math too quick in my head. Next one, into H4. Into H4. So 2x plus 4 times a positive 1, and that has to equal 0. Take that over, divide, x should equal negative 2. Next one, NaNO3. Na is positive 1, and oops, that's a positive, I swear. N is x, and then plus 3 times negative 2. And again, that has to equal 0. So negative 6 plus 1 is negative 5. Take it over to the other side, and I should get positive 5. And the last one, NH4Cl to Cl. So N we don't know, that's x, plus 4 times positive 1, and Cl is going to be negative 1, equals 0. 4 minus 1 is 3. Take it to the other side, x equals negative 3. So see how nitrogen can have a whole bunch of different oxidation numbers depending on what it's joined up with. That's why, like, the rules that we learned work for some of them, but then for some you can only figure out their oxidation numbers depending on what they're joined with. Nitrogen happens to be one of those. Okay, that leaves you 41 and 42 to do on your own. This hopefully will be enough to keep you going, or maybe I should just keep going because you were supposed to have tried these before I started, before you started to watch this. Okay, so let's do 41. 41 says, determine the oxidation number of carbon in each of the following. So carbon, in graphite, and in brackets it says it's elemental carbon. Well, if it's elemental carbon, then the oxidation number has to be 0. In glucose, do you know what the chemical formula for glucose is? It's C6H12O6, I believe. Yeah, I think so. And so we're looking for carbon, so there's 6 of them, 6x, plus 12 times positive 1, plus 6 times negative 2, and glucose has to add up, has an overall charge of 0. So we have 12 times 1, which is 12, and then we have 6 times negative 2, which is negative 12, so 6x, and that has to equal 0, and so guess what you get? X equals 0. Okay, for C, sodium carbonate. Were you able to figure out what sodium carbonate is? Carbonate is a polyatomic ion again, and it has a charge of negative 2, so this is going to be Na2CO3. Okay, Na we know has an oxidation number of positive 1. It's in the first column of the periodic table. Carbon we don't know, that's X, and there's 3 oxygens, so 3 times negative 2. And sodium carbonate is an ionic compound. Its overall charge, sorry, off the screen, is 0. So we have 2 plus x minus 6. In other words, x minus 4 equals 0, so x should equal 4 in this case. And then the last one, carbon monoxide. I know you know the chemical formula for that. It's just CO. So x plus a negative 2 has to equal 0, so x should equal 2. All right, and then in the last question, carbon can be progressively oxidized in a series of organic reactions. Determine the oxidation number of carbon in each of the compounds in the following series of oxidations. So now to do this one, you got to know what all these chemical formulas are. So the first one is methane, and hopefully you remember that from chemistry. It's just CH4, the simplest of the chains. And then it's going from that to methanol, which is an alcohol, CH3OH. And then it's going to